go. So just a brief introduction. Obviously, my name is Cory Bianchi. I've been a Java developer for the past 4.5 years or so, and currently I'm working in Intive here in Wroclaw, and I've been living here for about a year. And I wanted to talk about my motivation for this talk. I thought it would be good to cover this because this has been a focus of mine over the last 1.5 or 2 years. I wanted to be more active in the IT community, and design is not really taught in school, I think, at least in my experience. A lot of the programs you write are small. Sometimes they are all contained within a main method. So I wanted to build on that. And so some reasons why I think that you guys should listen is that there's less headaches for you guys and for us as developers. The code's going to be easier to understand. There's going to be less comments on code reviews, because personally I don't like getting that many comments, although comments are good sometimes. And the code is going to be easier to extend and to modify. So we'll be better programmers and things will be easier to test. My objective is to get more people to follow these principles, to keep these in mind as a reminder, to help you when you're programming, and just to jog some thoughts. So how to make your, the overview is just how to make your code cleaner, easier to modify and understand. And so some of the topics we'll be covering will be the formatting of your code, how you should be naming your classes and methods, also classes itself, the structure. We'll talk about what are good comments and bad comments, and we'll talk a little bit about objects and data structures. So the first thing we'll talk about is vertical formatting. And personally, I think reading like a newspaper article where your code is telling you a story is a really great idea, and it makes it easy to flow since we grow up reading books and stories. And one way to do that is having dependent function calls. So you could start from the top and have a function. You could see the function call, and it should be like the next one below it. And so these layers you could just read from the top down. And vertical distance helps with your formatting. Concepts that are closely related should be kept vertically close together. And this makes sense. That way you don't have to be looking all over your class to figure out where, what things are tied together. Things that are close, mean that they're working together. This also works with variable declarations. You don't want to have some variable declaration at line 2 and then use it at like line 50. It's too far, and a lot of things can happen. And the same with instance variables, you want to keep these at the top of the class, so that way you can get an idea of what the class is about. And you want to use most of these, if not all of them, within your methods of that class. So here's an example of vertical formatting, in this case vertical openness. So we can see that this bottom part here is actually difficult to read, or at least more difficult than the top part there. And that's mainly because there's no white space. The white space here allows us to pick out the scopes, allows us to pick out ideas, and so the vertical spacing is important. And just the opposite, vertical density is also important. So here is like too much openness, and there's also some clutter with the comments. This makes it a lot easier to read and more concise. You can spend less time reading it. And for horizontal formatting, it's important because white space, we use that to associate ideas that are together. And we can also use it to dissociate things that don't belong together or weakly related. And so things like that are spaces before and after operations. By having this space here, before and after the operation, we can easily see what's happening. But without that space, it's a little bit harder to read, and you have to spend a little bit more time on it. Horizontal alignment. I've seen this sometimes in classes, and I thought it was good, but realistically, I think having a list like this means that your list is probably too long. You probably have too many variables, and you probably need to create some classes. And this can allow you to create a smaller list, and by creating new classes, and you can just easily read over the lines And having the white space can give you misinformation here because maybe you just read the variable names without looking at their types. And indentation is also important. Here you can see that these two pictures are actually semantically and syntactically the same, but obviously this one is much more difficult to read. And by having the white space here on the left and the right side, the horizontal spacing, it breaks it up into something much easier to understand. So some recommendations that I have for formatting would be 80 to 120 characters wide. Try and have classes less than 200 lines, and encode your rules into formatters. We shouldn't be wasting time with formatting. We should decide on what our formatting should look like, encode it, and then allow programs and tools to format our code for us, and that's going to save us time. Next, we'll talk about some names. So we should be using intention-revealing names. Choosing a good name takes time, and you want to choose names, better names, when you find ones that are better than what you're currently using. So sometimes you're reading some old code and you're like, oh, what does this really mean? And it could be good to rename that to something else that's more understandable. Take time to speak with your teammates about names. Good names, I think, makes programmers happy because it makes the code much easier to understand. We could see here that in this small example, there's a lot of stuff going on, and if you spend some time, you could figure out what's happening here. But if we were doing something with like a game and cells, you can see by adding some good names that it's much easier and cleaner to read. So like, what does this 0 actually mean? It's a magic number, or this 4. So something at the 0 index, and we're looking for 4. Where here now we know, oh, 0 is the status value at that index, and 4 means it's flagged. But that's all hidden away, and we're reading text rather than magic numbers or constants. And we should avoid disinformation. So using consistent spelling, I think, is good. And sometimes you can see, I think, being here in Europe, that you might have American spellings versus English, British English spellings. So pick one form or the other. That way, when you're searching for something like the word authorization, for example, and you search it with the British spelling, well, maybe you miss some search results because in your code you have authorization with the American spelling. So it makes it helpful to use one spelling. And avoid using uppercase O or lowercase 1 as variable names. These could be easily interpreted as zeros or ones, and makes it a little bit more confusing to understand what's going on. And also, for me, I like using variables, something like accounts versus account list, because maybe I want to change my group, to be a set or to be a map, and I don't really care what my type is. The variable name won't change; it'll just be accounts. So I think avoiding types at the end is also a good practice. And using pronounceable names. So you can see here on the left, it makes it really hard to talk about this class with your colleagues, because if you were to really try and read this, it'd be like, did a record? I don't know, and then Jim Nimdis. It doesn't really make sense when you can really make pronounceable names and talk about what's happening. So you could say, oh yeah, in the customer class, there's a generation timestamp, and it makes it very easy to communicate. I would also say use searchable names. This is going to trump anything like numeric constant or single letter variable names. So if you have the number 7 and you try and search that, you might have that in 1,000 different places. But if you replace a portion of those with a constant, then you could pick out the piece that you really want, that you want to focus on. And member prefixes, these, we don't really need them anymore. I think these were used in the past because we didn't have great IDEs. But now that we have color coding, it makes it really easy to see what are member variables, what are local variables, even what are classes and interfaces. It allows us to see the differences in our programs. Interfaces and implementation classes, picking out names for these. I've always had some trouble. Sometimes I see this I-shaped factory starting with the letter I. I think this comes from some like C++ or type of programming. But really the class that's using I-shaped factory or shape factory doesn't really care about the I in here, whether it's an interface or not. So I would recommend using something shape factory. So if shape factory is your interface, your concrete implementation could be shape factory impl. Because this is going to be hidden away, especially if you're using like a dependency injection, the implementation class is not so important. What you really care about is the abstraction, which is your shape factory. And class names. Classes and objects should have noun or noun phrase names. You know, these are things, and things are nouns. So it's pretty easy. A class name should not be a verb. Self-explanatory. And opposite for the method names. You know, your methods are doing something, so they should have a verb or verb phrase name. And I would also say you want to pick one word for one concept. For things, here's an example as like fetch, retrieve, and get. They may mean the same thing for different classes, but you should stick to one name for one concept, so that way when you're going between classes, you know maybe a retrieve means that it's actually retrieving from a database. It doesn't matter what class it's actually that you're actually calling on, rather than the opposite, where maybe retrieve for one class does one thing, but retrieve for another class does some other thing. And that would be my second point here is don't use puns, where you have multiple concepts tied to one word. Functions should also do only one thing. I think most of you guys should probably know that, but sometimes we don't always follow that rule, and it's hard to tell sometimes, I think, what one thing is. So I've been struggling with that myself, but if you are aware of that, you can work on it and think about it. Functions should be small, and if you have blocks for like an if, else, or loops, they should probably have one line within that block, and that's your call to your function, because you're encapsulating some idea. And error handling is also considered one thing, so you should have a function that does error handling. And maybe for something like a try-catch, your try statement could be a call to a function, and your catch statement could be a call to a function. It'd make it easier to read. And we should prefer exceptions to errors, because it violates the command query separation, which I'm going to speak about a little bit later. And with errors, we need to handle them immediately, because you have like maybe if else's, and you have to catch things, or you're checking error codes, and then you're going to have to act upon that immediately. Whereas in exceptions, you could catch the exception, you could do something, and then continue to throw it, or you could just throw it automatically and let a higher level class deal with it. And have no side effects when you're creating your functions. So if you can see here, this is a check password method. So you'd expect it to just verify your password and nothing more. But you could see here at this point that we're initializing some session. And so this is a side effect because as a programmer and you're reading what's going on in the code, check password doesn't really mean initialize session. So this could mean maybe some temporal coupling that's happening. And this will make it harder to debug if there's something funny that's happening in your session and you can't really tell why, because only this method and maybe a couple of other methods were being called but are unrelated. So how many arguments should a function have? I think we should strive to have 0 arguments. It makes it that much easier to test, because within a function then it's only doing this one thing. You don't have these different variables manipulating what's inside the function. But you may have different types of setups for your class, so you could still test the function in multiple ways. 3 common reasons that you might have a single argument function. One of them would be to return a Boolean. So you're going to receive an object, call some methods on that object, and then you're going to return some value that you want to know about that object. Or you can have an object transformation. So maybe you receive this object, call some methods, and then you're going to return this new object. And sometimes you can also use it for events, which I guess is a little bit less likely. but you receive a you're going to just receive something from the event, and you would end up returning nothing in most cases. And here I have a question: should I pass in a Boolean as an argument? And the reason why I say no to this is because we said a function should do one thing. And typically when you pass in a Boolean to a function, it's going to do two things. Because if it's true, it's going to do something, and if it's false, it's going to do something else. And output arguments. Output arguments should be avoided. It's just as easy to return that argument as output, because you need some flow. You can have inputs, and the output should always be your return variable, rather than using output arguments. And descriptive names. I think you should just use them. I feel like sometimes I don't see enough descriptive names, so I use them. I know I spoke about that earlier. Verb-noun pairs. So once we have naming down, we have our verbs for our method names and our classes and our objects as nouns. We can have a verb-noun pair, and it makes it a little bit easier to read. I think a great example here is this assert expected equals actual. So if you guys are using JUnit, you know this will usually say assert equals. And for me, sometimes I have to check, like, what is the first parameter? Is it the equals? Is it the expected? Or is it the actual? And by positioning the parameter that you want in the actual position here, you no longer have to look at that. The method name tells you which position the arguments are in. And for command query separation, told you we'd come back to this. A method should do something, or it should answer something. So it follows that a function should do only one thing. Should do something, or should answer something. And with functions, we should not repeat ourselves. And this is a great way to refactor when you see duplications. As soon as you're starting to see one idea be in a second or third place, try and figure out, how do we get this into one location? It makes it easier for changes in the future. So now we're going to move on to classes. So let's talk about organization of classes. I think this is a good setup. I like this, where I have my public static constants at the top, then my private static variables, then I'll have my private instance variables, or my other instance variables, and then the constructors, and the public methods, and then the step-down approach. So this is what I mean is the functions with the dependency calls. So you'd have the function in the function, and you could just read it from the top down. Classes should be small. I'm sure some of you, if not all of you, have heard about the single responsibility principle. So they should be responsible for one thing. And we want to look for cohesion in our classes. So a class in which each variable is used by each method is maximally cohesive. And we want to strive for high cohesion. So to further kind of build on this, we also want to maintain cohesion. As we're adding maybe to our classes, we're breaking up functions into smaller functions. Now we're starting to have a bigger class. Well, we're going to want to create maybe some more instance variables and then create a class. And every time we create a class, we're now condensing ideas together, and we're taking this one big class that we had and maybe break it up into 2 or 3 classes. We're creating cohesion. And moving on to the next topic, comments. How do we typically use comments? I think that we will use them for adding clarity, maybe giving some additional information, giving a warning, or something like writing a to-do. And I never thought of comments really being that bad, but you can have bad comments, because comments can be misleading. They can also be hard to maintain. I don't know about you, but I've done it myself, and I've seen other people do it where they're changing some code, but then they don't update the comments. So when I see the code review, I'm like, wait, this comment doesn't match when I'm reading the code. So I know sometimes we can forget to do that. So the code is going to evolve, and the comments will decay. And we'll use the comments also to clarify the code, instead of just making the code easier to understand. So here are some examples. One is a redundant comment. So these comments here really don't add any value. The name of the member variable here is clear enough where this comment is not needed, and that's the same for these other variables as well. And it also breaks up the vertical density that we're looking for. I know I was working with someone that started trying to do this in his project. He was working in a project where they actually did this, adding comments at the top of classes. But this is not really needed anymore because we have version control systems. So not only does that version control system hold all these comments, but in most cases you can see all the changes. So this is unneeded and adds a lot of clutter to the tops of the classes. Don't use a comment when you can use a method. Here is a kind of a complicated statement inside this conditional if, and there's a comment here to help clarify that. But by breaking this complicated calls into something a little bit smaller, it's much more readable, and the comment becomes obsolete. And the position markers, these are really unneeded because if you have classes that are small, cohesive, you won't need to be marking different sections of your class because you're going to be able to read it with minimal scrolling. You can also have commented out code, and this is always bad. I don't know about you guys, but for me it's like I see this and I'm like, oh, is it important? Can I delete it? Why is it here? And then if you don't delete it, then it's there for like the next person to also think about those questions. So the best thing to do is, if you are the one commenting it out, make sure you try and delete that. Make sure you delete it before you put out a code review. If you're a code reviewer and you see this, tell them to delete that. There's no reason to have it, or at least discuss it. Maybe you need to uncomment it. And non-local information. So in this comment, it talks about defaulting to a certain port number, but as you can see in this method, all it's doing is just saving the variable. It has actually no impact on the port number itself. That's up to the caller, and so this type of comment here is not good. It belongs at a higher level. And so the last of the bad comments here that I have examples for are closing braces. If you're creating small functions, you won't really need these indicators of what these brackets mean because you'll be able to clearly see that, or at least click on your scope, your brace, and you'll be able to see what the scope is. And so this only really makes sense for your bigger methods, which we shouldn't be having anymore. And Java docs and public APIs, if you have Java docs for non-public APIs, it's just more maintenance, more upkeep. But if you're making your code clean and easy to read, these comments are no longer needed because your code tells you what you need to do, and that's all you really need. So let's talk about some good comments. So some good comments might be your legal stuff that you have at the tops of your classes. Or maybe you have some explanation of intent, why you're returning a certain thing. So here it says that we're greater because we're the right type. You can also add some clarification. It can be kind of difficult in this case for these compare to methods to see what's going on, take a little bit more time to read. So you can add some comments here and you see the cases that you're trying to compare in a more condensed format. And so this is kind of nice. But you have to be careful with something like this, that when you're creating this type of comment, that you have it correct because it's easy to make a mistake, and then when you're the next developer that comes along and reads this, it might not be correct. So I think if you handle this with care, it's good. You can have to-dos. In my previous company, we decided not to do to-dos in our code. We'd rather make issues or stories in our issue tracker rather than cluttering our code with to-dos. So I'd say this is probably on a project-by-project basis. But you can have some to-dos. That way, hopefully, somebody next time they touch that class or that file, they can do something about that. And amplification. This is to amplify some idea that you're trying to get across. You can also have warnings. Maybe there's something that you did in a function, and you want to give a warning about why you did that. That's also good. And then Java docs and public APIs, I think, are important because this means that you're sharing your code with others, and without the Java docs, it can be really difficult to program against that interface without some help. So moving on to objects and data structures. Objects hide their data behind abstractions and expose their functions that operate on that data, while data structures expose their data and have no meaningful functions. So something like a data transfer object. These are your POJOs, right? Your dummy things, dummy classes. We can also have hybrids, which are half object and half data structure. So that means that they're going to have functions that do significant things. They'll also have some public variables. And public variables could even be something that's really a private variable, but have public getters and setters. And because you're really exposing this this variable now through a method. It's going to make it hard to add new functions, having hybrids, and it's going to make it hard to add new data structures, as we will see in this next example. Kind of. So here I have some code about procedural. This is more of a procedural setup. So we have some data structures here, and then a class that knows how to handle those data structures. And then here's more of the object-oriented approach, and how each object knows how to find their own area. So in the procedural code, it's going to be using the data structures, and it makes it easy to add new functions without changing the existing data structures. And we could see that here. We can add a new data structure, and none of these previous data structures will change, and only this geometry class would change. In the object-oriented code, on the other hand, it makes it easy to add new classes without changing existing functions. So here we can definitely add a new class, and none of the functions will need to change. We only need to create the new class. The complement is also true. The procedural code makes it hard to add new data structures because all the functions must change. So when we add a new data structure here, we have to make sure we add it to all the functions of our geometry class. And object-oriented code makes it hard to add new functions because all the classes must change. So if we make a change to our shape interface to have some other method, then in order to satisfy the contract, then all these classes will have to change. Next, I want to talk about the law of Demeter. It says that a method of f of a class C should call one of these methods. So it can call anything within class C. It can call an object created by function f, an object that's passed as an argument to function f, or an object that's held as an instance variable of C. Basically, the method should not invoke methods on objects that are returned by any of the allowed functions. In other words, talk to friends, not to strangers. I think that's a really good quote there. Nice, I don't know what to call it, helper. And so I think about this as like 1 degree of separation. And the reason for this is because you don't want to have too much knowledge in your higher level classes. And when you have these train calls, maybe you call 3 or 4, 5 methods down, and you have like 1 semicolon at the end. This could be bad because if any one of those 4 or 5 method calls change, you change the name, then you have to change all the classes above that. But only having the 1 degree of separation means that none of that will affect you by calling the 3rd or 4th degree and changing that class. So to wrap up, For formatting, decide on rules amongst your team and use them. Use your formatters. Names, take time to find some good names and use them. For functions, make them small, make them do one thing. Have little to no arguments. Classes, remember they should do only one thing. And for comments, know when to use comments, know when not to use comments. And it's going to make the code easier to understand without them. Make the code easier to understand without them. And for objects and data structures, remember about the law of Demeter. Talk to friends, not strangers, and avoid hybrids. So some action steps I like to leave you with. Think about what steps that you can do to make your code cleaner. Start implementing just one or two ideas. It doesn't matter how small you start, as long as you can kind of build some momentum. Get some of that, get the gears cranking. And if you want to know more detailed information or have more examples, I only briefly covered some of the stuff. Read this book, The Clean Code, a Handbook of Agile Software Craftsmanship. And it's written by Robert C. Martin, as you can see here. And so I think we have a few minutes for questions, if you guys have any. No questions? Okay. Well, I think that's all I have then. Thank you very much.